It's an electrostatic interaction between the anions and cations that result from the transfer of valence electrons from metallic atoms to non-metallic atoms lead to the formation of ionic network. Instead of dependent molecules, why does this happen? Click on the image to launch a molecular dynamics stimulation of the reaction between metallic and non-metallic atoms. Select the initial number of atoms of each type and analyze what happens as the atoms react with ions are formed.
Okay, so it's asking like, why does this happen? So we have magnesium, right? So magnesium, we know, has 2 electrons in its valence shell.
Magnesium?
Magnesium. Okay? If we look at the periodic table, it's in the second column. And so it has 2 electrons. Yeah. And then we have oxygen right here. Okay? Oxygen we know has 1, 2, 3, 4, 5, 6. Okay? It has 6 electrons. Now we know that this guy has 1, 2, 3, 4, 5, 6 empty spots, whereas this guy has 1, 2 empty spots. Okay? So the question is, why doesn't this simply form a molecular compound? I mean, why doesn't it just go like this? Magnesium, 2, and then oxygen will share its, and then we go like that. Actually, does that work? No. Why doesn't it do like that?
4 and 4? Because it's unbalanced. Because this one can only balance twice. I mean, bond.
Well, the thing is that even under certain circumstances, this guy can actually bond 3 times.
The most.
I mean, in O3 we see that. We see oxygen going like this.
So follow the slides.
Yeah.
Okay? But that's a resonant form. But yeah. First of all, we're never going to see a quadruple bond. Okay? The strongest we're going to see is a triple bond. And second of all, these guys want to be stable. Okay? So they want to, because they can't form that quadruple bond, they're going to want to try to get their shell either completely empty or completely full. Okay? That's what they're trying to do. And so this guy, he's thinking, well, I would have to find 6 more electrons in order to fill up my shell.
It's just going to be hard.
Or I can lose 2. And this guy's thinking, well, I just need to find 2, or I need to find
Or lose 6.
ions to give my 6 away to. And so what they do is that this guy, he's also slightly more, well, not slightly, he's definitely a lot more electronegative. Okay? So this guy overall, he has a higher electronegativity.
So he's going to pull that.
Okay? And this guy, he has a low electronegativity. Okay? So that means that this one, okay, imagine that, like, these are tourists. Okay? This one has this is the popular tourist. No, not tourist, tour guides. Okay? Let's say that this guy's a tour guide, he has 6 customers and they all love him. And this guy, he's not as popular, he has 2. So what's going to happen is that when they get the chance, these 2 right here are going to leave and try to join somebody who they find a lot more attractive. Okay, and so that's what's going to happen here. This one's going to go there, and this one's going to go there, leaving this guy with a charge of 2+, and this guy with a charge of 2-. Okay? And so we got now this the supercharged atom. Let me see. It's going to be super small. Right? Yeah, it's going to be super small because when you have a positive charge, you actually shrink in size. So we're going to have that, and then we're going to have this guy, which looks like that. Okay?
Bigger atom?
Mm-hmm. And so this guy is positive, and this one's negative. Okay? And so we're gonna just see them kind of connected like that, magnesium, oxygen. But the thing is, because of their charge, they're not really technically bonded, okay? There's not like a connection really between these two. They're just really attracted to each other, okay? But at the same time, this guy is attracted to anything that's positive. So he sees this guy over there and he goes like, okay, I'm also attracted to you, I'm attracted to you, I'm attracted to you. And these guys are going like, yeah, we're attracted to you, we'll hang out with you. But at the same time, these two, they go like, oh, but there's another one right there, another one right there, another one right there, another one right there. Okay, and so they form this network. So this one feels attracted to this because overall this is a 2 negative and this is a 2 positive. So they feel that connection, they feel that attraction. And also over here, it's like with, yeah, like with magnets. They just, you know, they like being close to each other.
Okay. So the question here says, click on the image to launch a molecular dynamics simulation of the reaction between metallic and non-metallic. So which one will be metallic? Oxygen will be non-metallic, right?
Yeah, oxygen is the non-metallic, and magnesium is the metallic.
Okay.
The metal will always lose their electrons. The non-metal will usually gain it.
If I added the water,
Metals.
oxygen is really